Hello, ladies and gentlemen. I hope you're having a wonderful day. Absolutely wonderful. I'm having a great day. Going through the 2006 Grade 8 Gauss, and we are on the second last question, question number 24. In the diagram, the grid has 150 rows and 150 columns, numbered from 1 to 150. Very nice. In row 1, every box is shaded. In row 2, every second box is shaded, so it skips over the 1 and shades in 2. Skips over the 3, shades in 4. Skips over the 5, it would shade in 6, so all the even numbers are shaded. In row 3, every third box is shaded, so we skip over the 1 and the 2, shade the 3. Skip over the 4 and the 5, shade the 6. 7, 8, the 9. So every multiple of 3, and then every multiple of 4, then every multiple of 5 as we go along. Okay. So the shading continues in this way so that every nth box in row n is shaded. Which column has the greatest number of shaded boxes? So column, not row, because obviously row 1 would win. All 150 boxes are shaded. Which column has the greatest number of shaded boxes? Interesting. So, is there a way to tell the number of shaded boxes a column has? Well, let's sort of copy this picture and take a closer look at it. Four, 5, 6, 7. We'll do 8, 9, and 10. And I'll only shade in a little bit, see if I can notice any patterns, and then the greatest test for do I understand the pattern is, can I then work out, can I use my theory to predict an answer, and then work it out and confirm that that actually is the answer. So that's what we're going to try and do here. So that's column 3, column 4, column 5, 6, 7, 8, 9, 10, so we won't have to go any further than that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I may have to go further, but I'm not planning on it. If we need to, we'll keep going. But everything's shaded there. Everything, all the 1 row is shaded. And now we get to 2 here. And 3 here. Notice that nothing will ever be put in the 2 column again. He's done. We can say it's those 2 because we're always going to skip over him. The lower triangle is always blank, lower than this main diagonal, which is always it's always filled in. So the 7th row, 7th column always filled in. Let's take a look here. 3 and 3. I'm not going to continue filling out these 10s, so let's 8. The 5 would go in the 10 one, but so nothing with 6, and then we go to 12, and so we're sort of, we'll put the 5 there, but we're sort of full up. Okay. So, looks like 1 has 1 in it, 2 has 2, 3 has 2, 4 has 3, then we're back down to 2 for 5, 6 has 4. So, we have to sort of ask ourselves what pattern, 7 has 2. We have to ask ourselves, what do we notice? What's going on here? You know, why does 6 suddenly get 4 of them? Well, why indeed? Well, 6 gets the 1 from himself, he gets the 1 from 1, and then he also gets 1 in the 2 row and the 3 row. 2 and 3, how do they relate to 6? And why don't they relate in that way to 5? So it might be a little easier if instead of filling in, I put actual numbers here. The number of the row that's filled in. That's how I think I'm going to illustrate my pattern. So 3, 3, 3, 4, 4, 5, 6. And now if I take a look at the numbers in the 6 column, 1, 2, 3, 6, those are exactly the factors of 6. 1 and 5, those are exactly the factors of 5. 1, 2, and 4, those are exactly the factors of 4. 1, 2, 5, and 10, these are exactly the factors of 10. If I were to do 11, its prime, it should only have 2, namely 11 and 1. And we can see nothing else was going to be put in the 11 category. So as soon as we stop filling in with shaded squares and start filling in with numbers, we see number of squares in a column equals number of, so in column, I don't know, K, is the equal to the number of factors of K, numbers that divide evenly in. Okay. So, what can we do to use that to our advantage? So, for example, 9 should have 3 of them because it's got 1, 3, and 9. 12, don't even have 12 on here, but 12 it has factors of 1, 2, 3, 4, 6, and 12. So 12 should have 6 of them. It would get filled in, it would get the 2, it would get the 3, 1, 2, 3, it would get 4, wouldn't get 5, 1, 2, 3, 4, 5, it would get 6. 7 would skip over it, 8 would skip over it, 9, 10, 11, all of them would skip over it, would get 12 down here. So it does seem to work out. Our theory has predicted more numbers. 13 should just have 2 of them, namely the 1 and the 13 all the way down there. Okay. So we've made this connection. We're fairly confident in it. What do we do now? Well, I need to figure out which row has the most. Okay, is there a way to do that? Is there a way to do some calculation and say, oh, it's got to be, what numbers do I remember? 96. It's got to be 96. I think that was E. I'm not aware of any way to say, from the numbers 1 up to 150, this is the one that has the most factors. There might be a way, but I honestly don't know, and I'm not dumbing myself down to do this from a grade 8 level. I genuinely don't think there's a way to do this. But I do know there's a way to count the number of factors. And it's a multiple choice contest. I don't think they'd be able to ask this question if this were like the grade 9 Friar. But it's multiple choice, so we have 5 possibilities. I can take each one of these in turn and just say who has the greatest factors. Because if you hand me a number, I can tell you how many factors it has. If you give me a range, I can't tell you which one has the greatest number of factors. But if you hand me a number, I can tell you how many factors. I'll show you how to do that. And it uses a technique called prime factorization, which, I mean, you should know what a prime number is. For any number, there is a unique way to write it in terms of its prime factors. So 12 has 2 2s and 1 3. So 2 to the 2 times 3 to the 1. And when you have it written like this, the number of factors can be found by taking a look at these exponents, adding 1 to each of them, and multiplying. So 3 times 2, 6. And hey, we have 6 factors. Now, if we were to write this very, very fancily, we don't know what the primes are, but we call, first prime is P1. It could be 2, it could be 3, we don't know what it is. So this is in general what a prime factorization looks like. And maybe there are m prime factors, and each of them have this many exponents. So the number of factors is equal to E1 plus 1, E2 plus 1, all the way up to EM1 plus 1, and we multiply them all together. So this is a nice result. You don't need to know it in this advanced form, but it's good to know it. Okay, but now let's take it, and we're just going to apply it to very specific examples. So if you didn't get it from the example with 12, and you didn't get it from all that, I mean, there was hardly a number in there. P to the 1, P1 E to the E1, P2 to the E2, and so forth. You might not be ready for that. That's okay. But let's actually look at some working examples, and maybe you'll catch on. Okay. So we got 144, 120, 150, 96, and 96 wasn't E, it was D. But 144, 120, 150, 96, and 100. Let's just take a look at each of these numbers. I will give myself a little more space. 120, 150, 96, and 100. So first things first, we have to get prime factorizations here. And you can use your calculator. You can just sort of, one thing I do is I say, well, 144, I can divide it by 2, so that leaves me with 72. I can divide that by 2, that leaves me with a 36. And I can divide that by 2, and that leaves me with an 18. I can divide that by 2, and that leaves me with a 9. I can divide that by 3, and so I get my primes this way. So I've got 4 2s, 2 3s. And we can do the same thing with 120. Just dividing it with primes. I can divide it by 2, so we get 60. 2, I can get 30. 2, I get a 15. Divided by 3, I get 5. So this guy is 2 to the 3 times 3 to the 1 times 5 to the 1. That's how it's written in terms of primes. Okay, how about 150? Two, and that would leave 75. Again, if you need your calculator, go for it. There's a 5 there, and peel that off, you get 15, and that's a 3 and a 5. So I've got 2 5s, 1 2, and 1 3. All right, how about 96? I think it's going to be either 96 or 144. Because that 4 plus 1 is going to give me a 5, and that's going to get far and away. But 96 just might have enough 2s and 3s to do it. We'll see. 96 goes down to 48, and that goes down to 24, to 12, to 6, and then 3. So that's 5 2s, but only 1 3. I think 144's got this. And then 100, well, that's 10 squared, and 10 is 2 times 5. So 2 squared, 5 squared. All right, so I've got the prime factorization. That's a crucial step. Now, how many factors do I have? So we take 144, 4, so it's 2 to the 4, 4 plus 1 times, and then it's 3 to the 2, so 4 plus 1 times 2 plus 1. Okay? So we'll make sort of a column, number of factors. Because remember, number of factors is number of shaded boxes in that column. So it'll be 4 plus 1 times 2 plus 1. The plus 1s are there in every part of the formula. And that 4 goes there, and that 2 goes there. All right, how about 120? You'll get 3 plus 1 times 1 plus 1 times 1 plus 1. And we'll draw green arrows again, explaining where do these numbers come from. And now I think I'll knock it off with the green arrows. So 1 plus 1, 1 plus 1, and then 2 plus 1. 5 plus 1, 1 plus 1, and then finally 2 plus 1, 2 plus 1. So this is 5 times 3, or 15. This is 4 times 2 times 2, which is 16. Whoa! I did not expect 120 to take this, but it did. 2 times 2 times 3, 12. 6 times 2, also 12. And 3 times 3, 9 factors for 100. And if you wanted to double check, if you were a little unconfident, if you were unconfident in this, you might say, okay, well, what are the 9 factors of 100? You get 1, 2, 4, 5. So we get 100, 50, 25, 20, and then 10 right here in the middle. And that is 9 factors of 100. You're not going to find any more. So the 100 column is going to have 9 boxes shaded in. But it is, and I didn't even think 120 would make it, but 120 with 16 factors, we could even list them out. The row 1 will be filled. Row 2, 3, 4, 5, 6. Start working backwards here. 60, 40, 30. Divided by 5, and we get 24, 20, 10 and 12 certainly are in there. 2, 4, 6, 8 and 15. I think 10 and 12, but that's it. 2, 4, 6, 8, 10, 12, 14, 16 shaded boxes. So row 60 would be filled in. Row 30, row 24. So that was B. 120 was B, correct? Yeah, there it is. So, very nice, very interesting little problem. We had to know prime factorization. We had to know how to count number of factors. We also had to notice that pattern in the first place. We didn't dwell on that a whole lot. But it was crucial that you understand why certain rows are being shaded in a particular column. Okay? So that's question 24. We got one more to go, and that'll be question 25. Thank you guys, as always, for watching. If you want to, like or subscribe. And if you don't want to do any of that, I'll still see you for question 25 in the next video.